All right, everybody, let's look at the effective rate of interest. So the effective rate of interest gives the equivalent annual simple interest rate that would yield the same amount as compounding n times per year or continuously after 1 year. As you saw in Canvas, the compounding n times per year gives the effective rate of interest by, let me change colors. By 1 plus r over n to the n, and then there's no t there because it's only for after 1 year, minus 1, and e to the r minus 1. So I want to show you kind of where these formulas are coming from, or give you some intuition behind it. In the last problem, we had a $1,000 investment that offered 4.2% annual interest on a savings account compounded monthly. So we saw that the amount would be given by 1 plus 0.042 divided by 12 to the 12, and this was done in 1 year. And so the idea behind this effective rate of interest is that you can compute the interest just for this, right? So you can get your answer. So if you were to plug this into your calculator, you would end up getting, let's see, let me go back into my calculator. 1042.8, let's not round it, so 1042.818007. And if we wanted to find the interest for this 1 year, we would want to subtract 1,000 from this, and so the interest would equal 42.818007. So this is the interest that we got for 1 year on an interest on an account that had 4.2% interest rate compounded monthly. What the effective rate of interest does is we want to find the annual simple interest. That is, if this is our interest, and if we use the simple interest formula, I equals PR times T, but we know that that's going to be 1, we can solve for R. So that is, we'll get 42.818007 equals 1,000 times our R. And so this answer divided by 1,000 is going to give us interest rate. Let's write it over here. R equals 0.42818. Oops, I ran out of space. So 0.428 will work, meaning that we'll have and I forgot a 0 here. It's 0.0428. So when we change this to a percent, it's going to be 4.28%. So what the effective rate of interest for our example is for something that's compounded n times per year, is that you've converted the interest that you get compounded monthly to what it would be if it was compounded at a simple interest rate. And so this would be the rate. And so instead of going through all this work, it can just boil down for the effective rate of interest being 1 plus r over n to the n minus 1 and e to the r minus 1 for compounded continuously. Alright, so and if you wanted to just play with this example that we have here, you would take your 1,040, there will be no 1,000 here, so you would do your 1.0035 to the 12, and then get that answer in minus 1, and you would still get the same thing that we found here. So let's look at number 6. Suppose you want to open a money market account. You visit 3 banks to determine their money market rates. Bank A is going to offer you 5% compounded monthly. Bank B is going to offer you 5.04% compounded quarterly. And Bank C is going to offer 4.9% compounded continuously. We want to determine which bank offering is going to be the best deal. And so first off, when we consider this in terms of the best thing to do in this situation is to find the effective rate of interest, because it is based off 1 year, and what we want to do is find the highest effective rate of interest. So we're looking for the highest is best. Especially if we are trying to just save money. If we're doing other things, it might not be the best, but you're just looking to save the most money in this example. So let's kind of organize our work. So maybe we just can say BA for Bank A, BB for Bank B, and BC for Bank C. Aw, my first family's dog's name was BC. Okay, so let's go through and read this again. You visit 3 banks to determine their money market rates. Bank A offers you 5% compounded monthly. So let's just jot that down. And N is 12. Bank B is offering you 5.04%. N is going to be 4 because it's quarterly. And Bank C is going to offer you 4.9%, and it's continuously. So let's just maybe use E. So we're going to find the effective rate of interest for each of these. So it's going to be 1 plus 0.05 over 12 to the 12 minus 1. And this comes out to 5.116%. And for the second bank, we'll have 1 plus 0.0504, and then divided by 4, all to the 4, minus 1, and that's going to get us 5.136, so it looks like Bank B right now, percent. And when we find Bank C, it's going to be E to the 0.049 minus 1, the rate of the effective rate of interest. And when we punch that into our calculators, we're going to get 5.022%. So when we look at these effective rate of interest, we're going to see that we're going to want to go with Bank B at the 5.136%. So this is the best deal. Alright, so I hope you found this helpful, and I'll see you in the next video.